Hello everybody, welcome to the I Am IT Geek YouTube channel. My name is Shabazz Dart, and in case you have forgotten, I'm sure you haven't, but just in case, I am the IT Geek. Welcome back to coming towards the end of Module 2 of my AZ700 Microsoft Certification Exam Prep series. We are on part 2 today of the Virtual WAN Architecture topic, so that's 2 parts, so this is the second part. And then after this, I promise it will be the end of the module. We'll finish off with the monitoring networks episode, and then we'll move on to module 3. I think I've said that a few times, but we will, I promise. So yeah, as I said, coming towards the end of this topic, I'm going to be doing the theory as normal, and Mohammed Sajid, my good friend, will be doing a lab. And I think the lab today is around creating a network virtual appliance, an NVA in a virtual hub. So really good episode from Saj, video from Saj there. So yeah, let's get started with today's topic. So it's still on designing and implementing core network infrastructure, which is module 2. And as I mentioned, we are on part 2 of designing and implementing an Azure Virtual WAN architecture. So today we're going to talk about deploying a gateway into a Virtual WAN Hub. We're then going to go into configuring Virtual Hub routing, and then finish off with integrating Virtual WAN Hub with a third-party NVA, and that's the point where I'll hand over to Saj to do the lab around creating a network virtual appliance NVA in a virtual hub, should I say. It's in a lab as well. So let's go to this first topic. So let's deploy a gateway into a Virtual WAN Hub. So when you create the gateway, you can either use existing public IP addresses for the 2 instances of the gateway, or you can create new public IPs. And you'll use these public IPs when setting up the virtual WAN sites. Some sort of key settings that you need to understand. First of all is the active mode setting. On the virtual network gateway configuration page, you make sure active mode is enabled. Another setting is the BGP setting. So on the virtual network gateway configuration page again, you can, obviously it's optional, you can select configure BGP ASN. If you configure BGP, change the ASN from the default value shown that you see in the portal, and you can, for that sort of configuration, the BGP it can't be 65515, as that's used by the Azure Virtual WAN. Next, you would then create the Virtual WAN VPN sites, and here you specify the region as the Azure VPN Gateway Network gateway. The device vendor and link details, such as the link speed, the link provider, and the link IP address. Then, when you go through this process, you'll once your VPN sites are configured, you then connect the sites to that virtual hub, and then you download those VPN files for the sites you created earlier. And finally, you connect the local gateways and create and test your connections. So let's talk about configuring virtual hub routing. So a virtual hub can contain multiple gateways, such as a site-to-site VPN gateway, express route gateway, point-to-site gateway, and Azure firewall. The routing capabilities in the virtual hub are provided by the router that manages all routing, including transit routing between the gateways using BGP. The virtual hub router also provides transit connectivity between virtual networks that connect to virtual hub and can support up to an aggregate throughput of 50 gigabits per second. So it's a lot of throughput is that actually. So these route capabilities apply to customers using standard virtual WANs only. And again, you can use both the portal, Azure Portal, and Azure PowerShell to configure virtual hub routing. So let's move on to integrating Virtual WAN Hub with a third-party NVA, and then I will be handing over to Saj. So customers can deploy network virtual appliances, or NVAs, directly into a Virtual WAN Hub in a solution that is jointly managed by Microsoft, Azure, and third-party network virtual appliance vendors. Not all virtual appliances in Azure Marketplace can be deployed into that Virtual WAN Hub, so make sure you're aware of which ones can and can't. So when an NVA is deployed into a Virtual WAN Hub, it can serve as third-party gateway with various functionalities. It can serve as an SD-WAN gateway, firewall, or a combination of both. And deploying NVAs into a Virtual WAN Hub provides a few different benefits as well. So here are some of the key ones. Microsoft and the sort of partner network the partner worked together to validate throughput and bandwidth limits prior to the solution being made available to us as a consumer. Your virtual WAN NVA deployments are availability zone aware and are automatically configured to be highly available. And finally, a managed application is pre-qualified for provisioning and bootstrapping for the Virtual WAN platform. This managed application is available through the Azure Marketplace as well. And no hassle provisioning, and there's no bootstrapping either. Let's just stick with this topic of the sort of key benefits. Leveraging Virtual WAN's intelligent routing system, NVA solution peer with the Virtual WAN Hub router and participate with the Virtual WAN routing decision process similarly to Microsoft, so it's simplified routing. You've got integrated support, so partners have special support agreement with Microsoft Azure Virtual WAN to quickly diagnose and resolve any sort of issues that you might be having. You've got platform provided lifecycle management, so upgrades and patches are part of that Azure WAN service. This takes away any sort of complexity of lifecycle management from the consumer, which is us, who are deploying that solution. Finally, it's got integrated with platform features, so transit connectivity with Microsoft gateways and virtual networks, encrypted express route, so SD-WAN overlay running over an express route circuit, and virtual hub route tables interact seamlessly. So again, just going to talk about some basic use cases here before I hand over to Mohammed Sajid. So customers can deploy an NVA in every Azure region where they have a footprint. So branch sites are connected to Azure via the SD-WAN tunnels, terminating on the closest NVA deployed in the Azure WAN Hub. So you've got that any-to-any connectivity. Branch sites can then access workloads in Azure deployed in virtual networks in the same region or other regions throughout the Microsoft global backbone. Another use case is, that's for like security provided by Azure Firewall along with connectivity NVA. And customers can deploy an Azure Firewall alongside the connectivity-based NVAs. Virtual WAN routing can be configured to send all traffic to Azure Firewall for inspection. You may also configure Virtual WAN to send all internet-bound traffic to Azure Firewall for inspection as well. Sort of final use case I want to talk about is that sort of security provided by NVA Firewall. So customers can also deploy NVAs into Virtual WAN Hub that perform both SD-WAN connectivity and next-gen firewall capabilities. Customers can connect on-premises devices to the NVA in the hub and also use the same appliances to inspect all north, south, east, west, and internet-bound traffic. Routing is enabled. These scenarios can be configured via routing intent and routing policies. So, finally, it's a bit of a longer episode from me, that one. Let's hand over to Saj to do a demo. I think this demo is going to be around creating a virtual or an NVA in a virtual hub. So, over to you, Saj.
Thank you, Shabazz. So, Shabazz has just gone through Virtual WAN and Virtual WAN Hub. So, we're going to step through creating a Virtual WAN Hub, deploying a Virtual WAN and creating some Virtual WAN Hubs. So I've pre-created this demo just to step through the demo. What we're going to do is we're going to deploy a Virtual WAN. We're going to deploy some hubs. And if you've been following this series, we've deployed some virtual networks, VNet 01, VNet 02, and there's some VMs that sit in each of these VNets. So the VNet address space is 10.1.0.0/16. The subnet here, the default site 1 subnet is 10.1.0.0/24. If you look at connected devices, we have a couple of connected devices on 10.1.0.4 and 0.5. And then VNet 02 again, exactly the same. Connected devices 10.2.0.4, 10.2.0.5, and the address space is 10.2.0.0/16. And if you remember, VNet is a routing boundary. Unless you do something specific, devices can't route out of a VNet. And previously we created some VNet pairings to allow that communication to happen. So if you can see here, there's a VNet pairing created here, but I'll come back to this. This is created by the hub that we're going to create to allow the communications to happen. So when you're going to deploy a virtual WAN, again, search for virtual WAN. I've already been in here, so just virtual WANs, select, and then create a new virtual WAN. And the options here are fairly straightforward. Subscription, the resource group, again, we'll use that AZ700 resource group, the region you want to deploy it into. So we can deploy everything in the UK South. If you want, you can actually deploy this into a different region and give it a name. So as an example, Virtual WAN 001, and the standard SKU and the basic SKU. We're going to deploy the standard SKU, and like I said, I already pre-created this. So we're going to leave this and just look at the one already created. So if you look here in overview, we've got a virtual WAN already created, and in here we've created a couple of hubs. So to create a hub, under connectivity, select hubs and select new hub. And we've already completed the basic setup on the hubs. So we've given it the subscription and the resource group are pre-completed for you. AZ700 resource group, Am IT Geek subscription, the regions UK South, give it a name. So hub 001 as an example. Use an address space that you are not using. So as an example, I know that 10.0.10.7.0.0/16 is already in use and should come up. Okay, so you use an address space that's not in use in your environment, 10.7.0.0 as an example. Virtual hub capacity. So if you hover over the information that says routing infrastructure units determine the minimum throughput of the virtual WAN. So if you look at the drop down menu here, you've got 2 all the way up to 15. Actually, you've got more than that, 2 all the way up to 50. And smallest one supports up to 2,000 VMs. The largest one here will support to 50,000 VMs. So in our demo, we've already deployed the smallest one for 2 of them, and it says hub routing preferences HRP. So array routes wise routing preferences. So you've got express route, you've got VPN, and you've got ASPAP. Again, we left that as default as part of the demo, and we've created 2 of these. They take anywhere between 20 minutes, half an hour to deploy. And we've deployed demo hub 01 and hub 02. And then we've connected the hubs to our existing VNets. So under connectivity, virtual network connections, take a little while to propagate, a few seconds. It will get there, I promise. Just a little slow this evening. There we go. So to add a new connection, if we expand this out, if you look at the demo, what we have is demo hub 1 is connected to VNet 01 and demo hub 2 is connected to VNet 02. And essentially, it's allowing VNet 01 to talk to VNet 02 by repeating connection. That's going to be created when we create these connections within the hub. So if you look at our virtual networks, VNet 01, it has a peering connection here, but this was created when the connections within the hub were created, not created manually as we did in our previous demo. So to create a connection, you go to add connection, give the connection a name, hub 001 to VNet 001 as an example. Select your hub, subscription at Am IT Geek or a different subscription if you're using multiple subscriptions, your resource group. Select your virtual network. So we've gone hub 01 to VNet 01 and hub 02 to VNet 02. Propagate to none. Again, we've left this as default as part of the demo, and associate route table. I've just used the default route tables in here and propagate route tables on your demo hub. So I've selected propagate to the default route table on demo hub 1 and demo hub 2 because we want them to be able to communicate with each other. And propagate to labels. However, labels are logical groupings of route tables. Again, it's something we're not using, so I've just selected this as default in this demo and select create. Now I've done hub 01 to VNet 01, hub 02 VNet 02, and it creates the connections for you. And once the connections are created, it also creates the VNet pairing links for you. So to demo this, we still have 2 VMs. Virtual machines. If you look at the virtual machines, they sit in each VNet. So VNet 02, it has an IP address of 10. Demo 02 has an IP address of 10.2.0.4 in the 10.2 network, and demo 01 has an IP address of 10.1.0.5 in the 10.1 network. So I've already RDP'd this as part of the demo. we've got ipconfig. So that's 10.1 network. And if you look at the other machine, that should be a 10.2 network. Uh, 10.2 network. So if this works, we should be able to ping 10.1.0.5 and communicate via the hub that you've created. Hey, look, that works. Thank you for watching. Back to you, Shabazz.
Thank you, Saj. Again, another really informative, sort of really good demo there again. And you know what? You probably benefit more from Saj's demos than you will hearing me do the theory, but both just as important. So please do follow the labs. I can't emphasize the stressing of how important it is. All the links to the GitHub link to the labs are in the description. Any comments or questions, please do hit us up with a comment on the video, or you can get mine and Saj's socials in the description as well, LinkedIn and Twitter. Give us a follow, ask us any question you want, give us a tweet about our videos, also comment on the video, like the video and subscribe, get notified about my videos. I'm doing a lot recently, I've got a lot more planned, a lot of different topics, so do not miss out. So one more episode left in module 2, which is going to be monitoring networks. This time I promise, guarantee. So thank you for watching, and up until next time, goodbye.